In this episode of Finland Machining we are going to turn this piece of material into a shaft for this rotating welding position. Yes. Okay, so let's put this piece of material in. Weighs about 7 kilograms. It's heavy. So I have measured these to be about a little bit over 70 millimeters. This is 70 millimeters stock. It should go there. Probably. Yeah, okay. And now we just need to tighten it just even so slightly. This will become fun. Even so slightly, yeah. There you are. Well, not too much deviation, but we need to dial it in. 55, 54, 50. This is low, this is high. Okay, it moved. Well, it's quite good now. Let's go here, not with that one, with this one, about there, and let's see, this is now low, this is high, low, should be about, okay, now it should be there, yeah. There, okay, 200ths of a millimeter, and finally got this. And this is again, this is high, this is low, no, this is high, that's low, so that is high. Now it's inside 300ths of a millimeter here. I'm pretty sure this is the best we can achieve here easily. This might have moved a little bit. Yes, it has. So, okay. Let's see now. Mm-hmm. 300ths of a millimeter. Three-hundredths of a millimeter. Oh, finally. And now I really tighten these. That's tight, 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 and finally tight. Yeah, these are now done. Now we have a horrific stick out here, and I need to get a center here. So, well, we are going to use very sharp tool here with negligible cutting forces in order to get this, and we don't face it entirely, just the very center there, but let's see now. So. It's still leaving the nibble. how big is it? Okay. A little bit more higher. Like that. Okay, now it's in the center. Let's see where we are. Well, I don't want to jeopardize this one, so I will now accept this as is. There you are. Wow. So now, well, of course you need to clean this up. Yeah. Well, it's a center. And, well, it's okay. Well, even though I didn't face it all together, but the area where I made it is quite well faced. Turn this top side, I mean not just the top side, underside round, even. I believe this is not round. And what we are going to do, we are going to use this as a reference surface later on. We are going to dial on it and etc. Why I did try to dial it as good as possible, the reason for that was because I don't want to lose too much material. So I'm going to peel off as little as possible from this one. And yeah, I shall be using again this nice insert if it is still intact. Hopefully it is. Okay, and now we are going to set up the hard stop. And well, yeah, okay, it's belt driven. Our hard stop will be here. So yeah, it will stop before it crashes. It should. Actually, it should. Well, and I can actually take that off, but just use the VFD to slow down the speed. Let's see how it sounds. Yeah, I think we can use this one. Okay, let's see what we have here. Okay, and lock the compound, of course. multiple times, so how much more? Well, another 1/10 of a millimeter. Okay. And we have the slow speed, because this cut will take forever to finish. So I want to do it in one pass. Okay. Yeah, now it sounds like it's cleaning. See? Yeah, it's okay. And now it will run forever. This will take this cut, well, half an hour. So let it do its job, and I will drink my coffee. Damn. We need to take more. One more. Let's take 2/10 of a millimeter. Okay. So, the diameter here is now 51.05 maybe, and our goal on the bearing surface is well 50, and as well on our thread it is 50. What I will do now is to first take 1/2 millimeter away from this in 2 steps, and after that I leave the 1/2 millimeter for the bearing surface, and then what I will do, I will go down to our 50 millimeters. We are going to have here a thread, so that the major diameter will be 50 millimeters for that thread. Okay, now I'm setting the hard stop so that it stops after 20, this is now set up to 21 millimeters. So, first things first, I will put the the blade, the cutting blade against the end of the stock. So now that's there. And after that, I will simply loosen this one like that, and then I place this here in between like that, and then oh, this is it's dirty. Oh yeah, start sliding away better. Huh. Okay, so I put this one here in between like that. Maybe you can see it, it's there. Then I just tighten it first by fingers, and this is okay. I tighten it into place. And now, from this point on, now remember, I will show you that one too. Okay, now, so the blade, cutting blade was leaning on that surface. So our intention is to take 20 millimeters from here, actually 21. So I adjusted this to 21 millimeters. This is now 21 millimeters, so it can go only 21 millimeters. And then we retract this one, and we are ready to go actually. And this is the beauty of being able to run across hard stop. You can set these really exactly as you want, and it will feed on a constant rate up to that stop. So you don't need to manually stop in there and then do the rest by hand, which would leave the last mile as a very bad surface. So now we touch. Remember, we are 25, no, not 25, we are 28 hundredths of a millimeter too large here. So let's touch. That's that. So 28. That's 20. And it can be a little bit undersized because, well, we need to run the pairing. So I would like to take just a little bit more than that. That should now be our thread major diameter. Let's see. Done. Let's see what the dimension now is here. It should be, well, it should be, well, a hair under 50 millimeters, but just a hair. A very small hair, actually. Well, well, it's really small hair. It's 1/100th of a millimeter under. This is a threading tool I'm going to use. It's well, this was some commercial carbide tool, which I have ground. Here is a 60-degree thing with reliefs and everything. It's well, it's a little bit looks like it's handmade. There is a reason why it looks like it's handmade. One of the reasons is that it is handmade. Okay, that's one. And then we need because we are now doing a thread from here to there. I would like to have a thread escape groove here. I will use these. These are round, and when you put a round thing there, the thread will escape very beautifully into that one. It doesn't make any sharp corners. It just it looks nice. Well, it tries to chatter on me, definitely. Half millimeter done. Yeah. Okay, so now we are going to make a scratch pass and verify that we are running the correct thread here. So let's start and connect the half nut. This is 0.1 millimeter scratch pass. Okay, so let's check this out. I have here a thread gauge 2.0 millimeters. Let's see now. What is the result of this thing? If I put it there so you can see it, maybe you can see it better, yeah. So it looks like it's perfect. Okay. 0.25 millimeters deep here this time. But before I do anything else, we need some oil here. Like that. Let's see now. We should be ready to go. Point 0.5 now. Point 0.75. Yep. And 1 millimeter depth from diameter. We probably need a little bit more. This stuff here. Okay. And now I'm progressing with 0.1 millimeter steps because this starts to get heavy cuts. The deeper we go, the heavier the cuts will be. Well, it's just a little bit tight. So, well, let's see. Disconnected the half nut. Okay. That's nice. Okay. So then we make here it like this. Why did I disconnect the half nut? Oh man. Stupid. I'm stupid. Maybe this isn't that bad after all. Why did I disconnect it? Very stupid. Okay, yeah, it was the tops of the threads, and this is really nice fit. Doesn't wiggle at all. Exactly what I wanted. And let's not thread it in without oil, it might grab. This is very, very, very nice. Good. So, well, this is quite good actually. The bearing doesn't make any scratching noises and so on. And furthermore, what I will do now, I will mark something here, just here and there. So I know about where this contactor is running, and then I make here just a line so that I know that that's the point where I need to extend the 50 millimeter diameter area about 2.5 centimeters long here. And next step, I will put this one into the lathe backwards. So this shaft is now dialed in into my chuck. There you go. About 1000 RPM here. And it's really only one 0.1 millimeter cuts in order to avoid any strong cutting forces here. Well, we have a decent area there which is flat. Okay, let's take a tour. How to set up the speeds and feeds in this machine. First of all, we have the spindle speed. This is a gearbox, which you can select several speeds like that, now like that. And when you have the correct speed, when you think that it's correct, then you just push this lever down and it will engage that gear. There you are. And then, well, about the spindle speed, another thing that is impacting it, there will be a belt drive up here, which is then either driving directly the spindle or you can use a back gear. This lever is used to select either direct drive or back gear. Well, these are the ones that were originally in this machine. Furthermore, I do have the frequency, variable frequency drive to set the speed. I'm using nominal speed because it might become lubrication might become an issue, because if you are running it in very low speed, the gearbox might take damage of, I mean prolonged time, something like 2 hours running in a very low speed. That might become an issue. Okay. Then when you select the feed, first of all you should decide whether you are using geared feed or belt-driven feed. Belt-driven feed is more silent, but it's not precise. So with when you are doing threads, you should use geared feed, and otherwise the belt-driven. It's now set up for belt-driven. And then that's one part. And then in here we have a table of feeds, and in our case I'm using B here and here 1. This is also impacting the feed rate. So B1 is at the moment we are doing 0.776. Well, about 700ths of a, maybe 800ths of a millimeter per revolution. And you can ramp it up to here, and the fastest you can do is 0.3 here. Okay, and slowest is on the opposite corner. No, here we have it. Well, no, this one is the slowest you can do. It's really slow actually. So yeah, that's about that. And then, okay, this is how you select the speed and feed. Another thing I would like to show you, well, I have this piece of nitrile rubber, which I place here like this. There is a magnet. I place it like that, and this is just preventing this thing from spraying the things all over the place. Okay, and one more thing worth of mentioning is this hard stop. You can actually run this carriage against this hard stop, and it won't take any damage if you are using a drive. If you are using half nuts and the lead screw, then that would crash your lathe. So this one should be pulled away when you are, for example, threading. So not to accidentally drive onto that one. So yeah, so let's see what it does. I'm taking 1 millimeter cuts here, so let's go. It's a very tight, actually it's a very tight thread. Let's see if we succeed with not wandering hole here. Start very carefully here now. I think we got it. Yeah, good. I think that's deep enough. I don't want to risk breaking the drill into there. Okay. We need to lower the table and raise the head somewhat to get the clearance here. Okay, let's raise the head first. I'll take all these stuff a little bit away, loosen the head. Oh, that was bad. Did I chip my nice drill? Oh yeah, this drops. Wow, I have to check that one. I believe it's chipped, but lucky as I can do some. Now it's quite high. Okay, let's lock it there. Wow! Oh, that was really, and this is now sitting tight, really tight. Oh, it dropped really. Huh? What do you see? Didn't chip it. It did not chip it. Oh, oh well, lucky me. There was something, oh yeah, the vice got a really bad hit. Okay, I'll have this ring here to avoid it from, this is a MOS 2, MOS 3 to MOS 2 adapter, and it's not very secure. I need to put it there. Okay, just like that. And now, oh man, that was horrific. Okay, let's see now how we can go down. Okay, this is tight. Let's see if we have the capacity here. Well, it's quite near. 10 more centimeters, please. A little bit more, please. Yeah. I think we have the capacity. Yeah. Wow. Okay, let's see how far we can reach with. This one should be straight. Like that. Well, it's nice to have a drill press with some reach. So let's see how far we can go with the quill. We have to raise the table at some point a little bit. Oh yeah. But now I would like to see how straight, is it still straight? It should be actually. This shouldn't be, no, yeah, it is there. So, now align it with the hole. The table is now locked. And there is this, it's also locked. Okay. Let's see how it feels. Just a feeling about this. So we have to evacuate the ships quite frequently. And I will use, this is gearbox oil, hypoid oil. Well, better that than nothing. Yeah, it feels better already. There was some chip between the edge and let's see where we are at the moment. Well, now I turned this around, centered it, made it straight, etc. So we are ready to drill the other side now. Yeah, okay, just drill it. Yeah, end of travel. Oh, there you are. Okay, it's not entirely true. There is a probably 2 centimeter gap there somewhere. Rest of the drilling occurs in lathe. Started to drill the 29 millimeter hole into there. The depth of cut when we are halfway through is about at this point. So where we are at the moment is, let me see, yeah, so we are about there. So this side halfway through. Oh, this is, heavy drilling. Maybe. So now, squirt into the hole, and away we go. Yeah, true. That's true. Wow! I accidentally removed the drill from the chuck. Okay, from the taper, I mean. True. Okay. There is a bearing backside here. I put it there. And this will be like it would be in the actual situation. But this risen point here, the end of the shaft must come off. So now I measure how high is it actually. So there you are. Well, it's I believe it's 2.9 millimeters. Okay. Okay. Yep. And then this one also off, and this is not It's very, well, sloppy fit. Now 2.9 millimeters off from that. Well, 2.9 millimeters away. So I will now touch it first. For the next operation, this must be very clean. So I will put this stuff into there and wipe it with the paper. Hopefully it forces itself into the grooves. Yes, it does. Well, I have already brushed it with a steel brush. So I believe it's now, well, quite clean. And the same thing applies to this one. This also must be really clean. I will now clean this way. You have to be sure which way to put it there. Okay, that's the bearing. This stuff. I have two syringes which are the ends, and these are really old. So I will now apply some of this stuff here. Quite a lot actually. And I really hope it doesn't migrate into the bearings. Let's see if this is enough. It should be. Yeah, and that flux is then, let's see if it now takes it inside there. Yes, it does. And yeah, this stuff is actually poisonous, so you shouldn't be swallowing this. It might hurt. Okay, let's put something to this side as well. This can jam this nut, really. Okay, let's see now what happens here in the back side. Yes, you can feel how it okay, there you are. Yeah, looks good. Something like this. I hope this works. It is my belief that that is enough. The soldering of this, I will heat this up well around under 300 anyway. And then I have this solder which I will be adding there. It's really thin, but yeah, not much is needed. But this is really thin, so I don't know. Let's see how much I need to add this one. But anyway, now I will warm it up and yeah, until this solder paste melts. And this will be, I will be using my butane torch in this one. Well, you could, and well, you have to be a little bit slow here. So I'm heating this up on the outer ring. Well, it's quite massive, so okay. This shaft, well, it's now ready. The shaft, yeah, and it I soft soldered it to this backplate because the soft soldering acts like a thread lock, and furthermore it conducts. Silver soldering would have been an option, but it's too much heat because we have to have the bearing there while doing that. Okay. So the next thing we shall be doing is the nut and pulley system at this end. But this will be in the next episode of Finno-Ugric Machining. Till then, see you!